Good morning, good afternoon, wherever you are. Hope you're having a good, safe day. Thank you for taking the time to attend this presentation, where I'll be talking to you about migrating and operating your business-critical analytics application using Azure HDInsight. I'm Arindam Chatterjee. I'm the Principal Group Product Manager at Microsoft, running the HDInsight business. You can reach me at any of these contact points. All right, without much further ado, let's get started. So for those of you who may not know, HDInsight, what is HDInsight? HDInsight is an enterprise-ready managed platform for open source analytics in the cloud. But what does that mean? What are we about? First off, it is about open source analytics. Our goal is to provide for our customers the most popular Apache-based analytics projects, starting from data ingestion all the way to ad hoc exploration. We want to make sure that each of the popular tools at each step in that journey is covered. So we were one of the first cloud providers to offer Apache Hadoop 3.1, and at this point, we support Spark 2.4, Kafka 2.1, HBase 2.0, and so on. And as our customers demand, we do keep updating the versions of these various analytics projects from time to time. But most important, because we are completely open source based, what this means is that you can actually migrate your application, make it portable as you move your applications from your on-prem environment to the cloud, or from any of the other clouds to Azure. And because, again, we are based on open source analytics, we are able to very quickly partner with any of the very innovative ISVs that are out there to make sure that their applications are running with HDInsight. So any applications that you are using on premises can easily be ported to run on Azure. Now, even after we have produced, you are able to run these analytics projects in your environment. What you really need, what enterprises have really asked us is, these projects have to run in the context of their enterprise requirements. Enterprise requirements around security, monitoring, cost control, etc. Now, Azure itself is a great platform that offers many of these features. So we integrate these open source analytics projects with all these capabilities in Azure. So specifically for scalability and performance, we offer integration with Azure Storage, with ADLS Gen 2, and many of these other services, including for security, things like Azure Key Vault, Azure Networking, VNets, etc. For monitoring, we offer integration with Azure Log Analytics, and of course, you have access to Ambari. For high utilization and cost control, which is very important for a lot of our customers, we offer Autoscale. And security, which is where most of our investments, recent investments have gone into, we offer multi-factor authentication, Azure AD integration, strong network isolation using virtual networking, and service endpoint policies, etc. And more recently, we have also added support for end-to-end encryption, from encryption in transit to encryption at rest, etc., through customer managed keys. So when you look at the entire package, HDInsight, it really becomes the best place for you to run your open source analytics in a secure manner, in compliance with your enterprise requirements in the cloud. And you shouldn't just take my word for it. Our customers are our best, a best testament to what they find to be the most useful in the cloud. We have customers who are going from, all the way from manufacturing industries to retail. Customers like Johnson Controls and Myntra for retail have all successfully used HDInsight for their environment. So I'm not going to go too much into marketing. So let's dive into dive into the solution architecture. What are those customers? What are they trying to do on HDInsight? Now, HDInsight as a service has been around for more than 6 years. 6 years back, when we started, most of our customers were building batch-oriented applications. So they would get batches of data, they would ingest batches of data through tools like ADF or Uzi and disk copy, etc., to move batches of data from their on-premise systems to the cloud, to HDInsight. And then you would use things like Pig or Hive, or more recently Spark, to clean the data, curate it, and prepare it, and convert it into structured data, typically Hive tables, and store them in a remote data store, HDFS compatible data store, like Azure Storage or ADLS Gen 2. Once the data is in, the structured data is in, then you can use any number of tools to access that data through a serving layer. Typically, customers would use something like HDInsight, Hive LLAP, or Spark. But it is possible to use other technologies as well to access the same data. Our goal at the end of the day is to have ADLS be the data lake for you and use a compute environment of your choice on top of that data. Now, more recently, what we are observing our customers do is really go into the streaming space. So they are trying to now ingest real-time data, typically through an open source system like Kafka, ingest the data, perform some stream analytics on it. Now, that could be Spark streaming. Storm used to be very popular on HDInsight, but more recently, customers are really favoring Spark streaming and have started to ask for Flink as well. And that would be another way of performing real-time analytics, stream analytics on top of the data coming in. But ultimately, the data coming in the hot path would also land in ADLS as the data lake. And once it's in there, more of your long-term batch processing on the same data becomes feasible. Now, on the visualization side, because we are, again, based on standard protocols, JDBC, ODBC, etc., any number of these tools, like Excel or Power BI or Tableau, etc., can be used to explore the data that is generated and curated through HDInsight. Now, as I mentioned before, this entire ecosystem for security, for monitoring, for data governance, integrates very deeply with a number of other Azure services. And that's Azure Data Factory for data ingestion, Azure Active Directory for authentication and identity management, network security groups for network security, log analytics for monitoring, and finally, Azure Key Management Services, so Azure Key Vault for your key management. So this is a typical architecture that our customers build using HDInsight. And so the possibilities are certainly numerous. Now, when you think about how do you now move this architecture, which most likely you have built on premises as well, how do you now move that to HDInsight? What are the considerations? What are the best practices and patterns and some new innovations that we have done in this space that you can take advantage of? So this migration can be a complex task, and you're going to get pulled in all sorts of different directions. So what is the key things that you should consider when you're planning migration of what is already a very critical part of your on-premise applications? When you're considering migrating your crown jewels, if you will, to the cloud, what are the things that you should keep in mind? So first of all, what we recommend is the migrate, optimize, modernize pattern. So what is that? First off, let's get your applications to the cloud. That's the most important thing. Why? Because the cloud by itself offers a bunch of advantages. around elasticity, cost, etc. So you want to be able to move your applications. To a large extent, you should try to lift and shift your application to the cloud. And so take the applications, the frameworks that you're familiar with in a way that is non-disruptive, and it is cheap and it is fast, move that to the cloud. That's the migrate step. When you move to the cloud, then you have to start thinking about, okay, how do you optimize for the cloud? And what is optimization? Keep in mind that on premises, your Hadoop clusters typically have your data and your compute running on the same environment. However, in the cloud, these are two separate things. Your compute is running on VMs, your storage is in a remote location, typically in the same region, but it's not co-located on your HDInsight cluster. That's what gives you the ability to independently scale either your compute or your store as per your requirements. But this brings up some interesting performance challenges at some point, and you need to optimize for that. And as you will see later on in the presentation, we have done some optimizations, built some features which allow you to optimize for the cloud. Now, you certainly have to think about HADR. You have to think about compliance and security. What may not have been possible on premises with a Kerberos-based environment, something like multi-factor authentication, now actually becomes easier to do in the cloud. You have to start taking advantage of that. So that's what we would call an optimization step, which doesn't change your application too much, but certainly lets you take even more advantage of the cloud beyond its core values around cost and elasticity. Now, once you have done that, then comes your modernization step. In the modernization step, now you're really looking at going towards a more SaaS-like experience or a more true PaaS-like experience, such as a job service form factor. So instead of creating a cluster and having to manage the cluster, even though a lot of the overhead is taken by us as the service provider, you still have to think about creating a cluster, managing it, cost control, utilization, etc. You may want to use a job service, and that requires some changes to your application. You could think about moving your old Hive scripts over to Spark. You could start thinking about integrating with things like Presto, for example. So the newer projects that are more born in the cloud that becomes available. So now you can think about moving it and taking advantage of those kinds of capabilities. And now these things, while in this diagram it shows in a serial way, really doesn't have to be serial. We have talked to customers who have hundreds of applications. They might choose to move some of their applications and follow this pattern of migrate, optimize, modernize. Whereas for some other applications, they may choose to keep them on premises and then modernize directly when they're moving to the cloud. That's your choice. And with the tools that are available on Azure, we make all of that possible. So you've decided to migrate. You've decided, looking at the migrate, optimize, modernize pattern, you've decided to migrate. That's your first step. You want to lift and shift. But there are still a lot of considerations. Which analytics engine should you use? You have Spark, you have Hive, you have Pig, and there is advances being made in all of these three things, three areas. Which one should you pick? How do you secure those workloads once they are running in your HDInsight clusters on Azure? How do you secure those clusters? What are the considerations there? How do you monitor? How do you get alerted when some things are going wrong? How do you control the costs? High utilization is always an important consideration for our customers. As you know, the cost per unit cost of big data cloud is cheap. However, when you do a lot of it, your monthly bill can actually be fairly high. So cost control is a really important consideration for all of our customers. Then what are the tools? Are there new tools that your developers have to learn, your data scientists have to learn? If so, what are they? What are the options that they have? Can they use Java? Can they use .NET? Can they use R? Which tools, which developer environments do they use? These are all important considerations as well. And last but not the least, when you made the right decisions across all of these, how do you now take that final step? How long does that final step take for you to move your applications from on-premises to the cloud? Now, over the next few slides, I'll touch upon some of the key things in each of these areas. But let's start with the analytics workloads. So one of the main things that we have done in the last 6 months is we have, as Microsoft, have released our own distribution of all the Apache projects. Now, as you might know, those of you who are familiar with HDInsight, in the beginning and up till recently, HDInsight at its core was built around the Hortonworks HDP distribution. We have been partners with Cloudera for a very long time, and we continue to do that. But now, more recently, we have decided to develop our own distribution, which is 100% compatible with HDP. But we have decided to develop our own distribution and release it through HDInsight. So today, if you create an HDInsight 4.0 cluster, then you are going to be running the Microsoft distribution. Now, why have we done that? 3 primary reasons. One, we really want the Apache distributions to be optimized for the cloud. What does that mean? We want faster release cadences. So as bug fixes, features get introduced into the Apache trunk, we want a very quick turnaround and make those available to you as our customers. We want to get new Apache projects. There are innovations happening all the time. And as soon as our customers, we see enough customers asking for some of these newer projects, we want to be able to pull that into our distribution and expose it through HDInsight as quickly as we can. We want these distributions to be Azure native, rather than be, the kind of tied to the on-premises world. An example being, Kerberos as the native authentication and identity system on premises. We know that the world is moving towards more cloud-friendly modern authentication systems like OAuth, for example. So we want our systems, our projects, and our distribution to be optimized for the cloud, to be natively integrated with some of our Azure services, whether it is newer features in Azure storage or newer, more modern authentication systems. Last but not the least, smart and simple. Now, Microsoft has had a long history of running open source systems, and certainly large big data systems. And there are a lot of learnings from it. A lot of it has to do with automatically helping the developers with identifying issues like data skew, for example, job playback. So in the area of monitoring, troubleshooting, debugging, we have learned a lot. And so we want to be able to quickly turn around and offer those capabilities to our customers. And so now all of this becomes possible with the Microsoft distribution that as I mentioned before, is now available as part of HDInsight 4.0. So having said that, now let's jump into this common question that we get asked. So a lot of our customers who have had projects that are on-prem clusters, on-prem applications that have been built for last 10 plus years, a lot of them are on Hive. And so when they are now Hive or Pig, and so when they're moving to the cloud, they will ask that question, what should I use? Should I use Spark or should I use Hive? Now, there is no real right answer. I think both Spark and Hive are evolving. Of course, Spark is evolving in a much faster pace at this point in time. And so if you're looking at data integration and ETL type scenarios, then really, Spark has, while you could use both Spark or Hive, Spark is really the tool of choice or the framework of choice at this point. If you're doing machine learning, then especially on unstructured data or even structured data for that matter, then Spark is definitely the clear winner there. Now, in the data warehousing and BI reporting space, though, we have seen Hive LLAP being able to meet much higher concurrency requirements. And if you have your data in sort of more legacy formats, if you will, ORC, etc., then Hive does tend to perform better in those scenarios. And so we do recommend that, and we do see our customers also continue to use Hive LLAP for those scenarios. Now, in practice, while it is always easy to provide recommendations, what do we see our customers actually doing in their environments? Even customers who have already moved their applications to HDInsight, what do we see them do? Typically, we are seeing both Spark and Hive being used together. If you're using HDInsight 3.6, then typically this happens through a shared metastore. If you're on HDInsight 4.0, then you can actually use the Hive warehouse connector, which is available in Hadoop 3.0. So you can use that to make let's say Spark for all the data engineering work, output to a Hive table, and then use Hive LLAP to query the data which is sitting in your Hive table. So this is a very common pattern that we see, and perhaps over time this mix will shift to more and more Spark as we have as Delta Lake takes hold and becomes more and more popular. We do expect Spark to become the more dominant across the board, and not just on the data engineering side. Okay, so the other project that we are making a lot of investments on is Apache Kafka. Kafka, everybody knows it's a great tool for data ingestion. In particular, we are seeing a lot of very interesting use cases that customers are putting Kafka into. And so, we have integrated Kafka with Apache Ranger. We have introduced features like bring your own key encryption. Certainly, as part of our enterprise enterprise requirements, we meet all the standards requirements around HIPAA, SOC, PCI, etc. And we are working very closely with our ISV ecosystem, whether it is lenses, stream sets, etc., to make sure that their monitoring applications, etc., continue to work with HDInsight Kafka and provide you a great all-round experience with Kafka. In our roadmap, we do have some features that we are adding around schema registry, cluster upgrades, etc., that will show up very soon with Kafka. Similarly, HBase. Now, HBase, I mentioned earlier, we do have on HDInsight clusters, we do have the store separate from the compute environment itself. Now, while this is, works great for most batch-oriented systems, Spark, Hive, etc., HBase, on the other hand, does have a very unique store access pattern. They tend to be relatively small writes, but perhaps very frequent writes. A lot of compactions that can happen depending on your settings. And so we have seen that on its own, by default, an HBase application running against a remote multi-tenanted store, does small blips, small spikes in latency, etc. at the 95th percentile plus, can have an adverse impact on the performance of the HBase service itself. And so to work around those features, those issues, we have introduced a lot of optimizations. So what we call enhanced read and accelerated writes. So we are taking advantage of premium blobs, and for the write-ahead log, we take advantage of premium managed disk. And by doing that, when we have measured this feature and benchmarked its performance, particularly the YCSB benchmarks, we have seen for enhanced large reads, we have seen up to 25 times greater throughput, much faster, almost 11x lower latency when you're writing to premium blob, reading or writing to premium blob. And for accelerated writes, particularly the write-ahead log, we have seen almost 8x greater throughput, 3x lower latency. But perhaps, even more important, or certainly as important, is the predictability of it. We have been able to, by writing to the write-ahead log to the premium managed disk, have really gotten a very predictable latency and performance profile when doing that. So a lot of our large customers have actually moved things like online shopping catalogs, etc., which are directly tied to their front ends, their shopping sites, to an HBase cluster, and it is holding up really, really well. So we're quite happy with the performance. More importantly, our customers are very happy with that performance. So this would be an example of what you would do as part of the optimized step once you get to the cloud. You lift and shift to and migrate to HDInsight. Once you're there, you start to use features like enhanced writes, accelerated writes, to take advantage of certain cloud features. So now you have decided what engines to use. So let's talk about security. How do you secure your workloads end to end? Now, HDInsight follows a shared responsibility model for security. What does that mean? The virtualized infrastructure, the physical infrastructure, you as a customer don't ever have to worry about it. That's our responsibility. We as Microsoft, as Azure, take care of that. For everything else above that, network security, operating system security, etc., all the way to data access security, at each layer, we provide a bunch of features that enable you to get a good defensive depth measure in place. Now, what does that mean for you as a customer? It's your responsibility to understand the features that are offered at each of these layers and use the features as per your requirements, your enterprise requirements, depending on the sensitivity of the data, the criticality of the application, the users who are going to access. Depending on those requirements and your corporate policy, you pick the feature that you want to use and how you want to use it. Now, certainly our goal is to make sure that it is very easy for you to use all of these features together. And it doesn't become too complex to set up all of these security features at each of these different levels. And you have good visibility into the end state, the security posture of your cluster as a whole. So this is certainly work in progress, but we have made sure that right now you have a way of achieving the security requirements, meeting the security requirements that you might have. I've called out certain of all these features, some of the more newer ones, and I'll go down into a little bit more detail in the following slides. So first off, modern authentication with the HDInsight ID broker. Now, those of you familiar with on-premise clusters, they're typically integrated with, they use Kerberos as the authentication mechanism, and it's really hard in that environment to do multi-factor authentication. But with some of our customers, loading very simple processing and loading and processing very critical, sensitive data in the cloud, they want the modern authentication. They want multi-factor authentication, smart cards, phone authentication, and so on. And so what we have enabled recently is the ability to use OAuth and MFA to log in to an HDInsight Spark cluster or a Hive cluster or a Kafka cluster for that matter. So once this is enabled, you would log into Ambari using OAuth and MFA, single sign-on experience. So if you have already used OAuth to log into any other Azure service, when you get to Ambari, we would enable single sign-on for you. Now, one of the key things for those of you who are familiar with HDInsight, previously we would require your on-premise legacy password hash to be synchronized to the cloud. With the addition of this feature, one of the good side effects of it is that those particular password hashes are no longer required to be synced. We have made sure that all our tools, IntelliJ plugin, for example, VS Code, browsers, of course, they work with OAuth, but all our tools, etc., are all updated and can use OAuth to log in to the HDInsight cluster. We also have sample code available for old tools like Beeline. If you're using Curl, a Curl script to submit Livy jobs, then some sample code around that to use OAuth to log in, to do the same logins. So a great improvement that we would love for you to try out. Again, an optimization that is possible for you once you get to the cloud. Now, a very common question that we get from customers is on premises, you are behind the corporate firewall and your HDInsight clusters are not visible to anybody from outside your enterprise network. When you put that HDInsight cluster, you migrate that HDInsight cluster to the cloud, your Hadoop cluster to the cloud. What happens? How visible is it at a networking level out to the external world? Now, the picture you see in front of you here is the default setup for an HDInsight cluster. Every HDInsight cluster has two public IP addresses that are exposed by the gateways. And so these public IP addresses are meant to be used by our management plane to monitor the clusters. That's what allows us to provide the service that we provide as part of HDInsight, the monitoring capability, patching, and so on. Now, you as an administrator, what you would do in order to start restricting access to your HDInsight cluster is create a VNet, a subnet, and enable service endpoints. You will be able to restrict network access to your storage system, to your storage account, to any SQL databases that are serving as your, let's say, your Hive metastore. Then you would create the HDInsight cluster within that subnet. And lastly, you would create some NSG rules that at the very least allow our management plane or the control plane access to your cluster. You can potentially block everybody else and allow your users to only use the internal IP addresses that are not visible to the external world. But those two public endpoints that our control plane needs access to, those two public endpoints are visible to the public internet. Of course, if you set up the right NSG rules and they're set up properly, then nobody else outside of our management plane can actually access your cluster. However, it is visible. So the feedback we have gotten from our customers is, can you deliver a truly private cluster? And I'm happy to announce that we now have private clusters feature in preview right now, going to GA very shortly. But once it's very simple setup through the UI. But once you choose that, you truly have no public IP addresses. So your cluster is completely invisible to the public internet. So how does the functionality that we were providing from our control plane, where our control plane was monitoring the HDInsight cluster, how does that work? What we have essentially done is to reverse the flow. So instead of our control plane contacting the cluster and monitoring it, we have reversed the flow so that the cluster is reporting at frequent intervals, is effectively reporting the status to the control plane. And so this allows us to operate an HDInsight cluster with no public IP addresses, and you are truly hidden. Now, customers have asked us for the next level, which is they want to be able to, even for internal applications, users that need to contact the HDInsight cluster, they want to contact it using private endpoints. If you have that requirement, then great, we meet that too. For every HDInsight cluster, if you choose the right option, we can deploy a private link service. It's a standard load balancer feature. We will enable that for you, and you will be then able to access the HDInsight cluster through private endpoints. So we are very excited about this feature that we have just delivered, and I hope that all of you will get that peace of mind that now you can have a truly private HDInsight cluster once you migrate it from your on-premises to the cloud. So let's talk about monitoring. So in HDInsight, you have several options. If you're managing a single cluster, you are used to Ambari on premises, you can continue to do that. Ambari is the default cluster management utility that is available to you with every HDInsight cluster. We also have HDInsight cluster metrics. You can go to the portal. You can see things like, the trends of your gateway requests. You can monitor the size of your clusters if you have enabled auto scale or you're scaling clusters on your own. You can see what the size of the cluster was. You can set up some alerts, etc. on that. But we also integrate with Azure Monitor or Azure Log Analytics, as it used to be called. What this allows you is to be able to now collect metrics from all your clusters. We have some customers who run hundreds of HDInsight clusters in parallel. And so they want to build a single dashboard. And so the way to do that is Azure Monitor. And I'll give you a taste of what that looks like in the following slides. This is certainly a very active area of investment for us. More recently, in the last 9 months or so, we have added Ambari alerts that now can be moved from the cluster to Azure Monitor, and so you can actually see the Ambari alerts from across all your clusters. Gateway logging attempts, SSH logs, Ranger audit logs, all of these can now be pushed and viewed in Azure Monitoring. And so this is what looks like when you have all these HDInsight clusters that are all reporting their metrics, their logs to a common log analytics workspace. And then you can build all sorts of visualizations on top of it. And what we find our customers do is when they move from on-premises to HDInsight, when they migrate, they start with Ambari because that's what they're used to. That's what the skill set is. But as they start to optimize on HDInsight on Azure and become more familiar with Azure services like Azure Monitor, Azure Log Analytics, etc., they start to create these fairly sophisticated dashboards, as per their requirements. And so they will continue to use Ambari for upper cluster management, but really what they're trying to also graduate towards is, collecting all of these metrics from all their clusters and showing it in a customized dashboard. All right, so let's move on to cost control. So on premises, the typical pattern is to create a cluster, a very large cluster potentially, and leave it running 24 hours a day, 7 days a week. Now, you're worried about utilization. These are again on premises. These are co-located, data and compute are co-located. So as your data grows, you are adding VMs, and you're not necessarily using the compute. Now, in the cloud, that problem goes away. Your cluster is independent of the data. But the pattern that you have of running a static large cluster, where you have to, in some sense, provision for peak load requirements. What should you do on the cloud? So a very typical pattern that we see customers do is create a cluster, use it for several hours, maybe several days, and then shut it down. But a more recent observation is customers will try to now run multiple different workloads at different times of the day to try and drive utilization up. But they still want to make sure that the utilization truly is as high as it can be. And that's where autoscale comes into the picture. You're not necessarily turning off the entire cluster or shutting down the entire cluster. But so you want to keep the cluster running. But as your scale requirements, load requirements keep going up and down, you want the cluster to intelligently move up and down as well. And so we've made this pretty easy for Spark, Hive, MapReduce, and LLAP workloads. HBase is in progress right now, it's still in preview. But for the other workloads, as I mentioned, Spark, Hive, etc., this is already in GA. Very easy to use for these clusters. Just go to the UI, and of course, all of these are available through command line as well. You can set up a load-based range. So you can say, I want my cluster to be anywhere from 3 nodes to 300 nodes. And then we will monitor some key metrics in the cluster, typically CPU usage, job count, etc. And as we see this trend, we will scale the cluster up to 300 in the example, or down as needed. The second thing you can do is create a schedule-based autoscale. This is a little bit more typical for an LLAP cluster that is being used by perhaps your data analysts. They come into work at 8, 9 in the morning, so you can set up a schedule which says, hey, ramp up the cluster at 9 a.m. And then maybe at sometime in the evening, 10 p.m. in this example, scale it back down to a much lower number of nodes. And maybe you're still using it for other types of processing, but your load requirements are not that high. But this is very typical of a scenario where you actually know what the pattern of usage is. So pretty easy to set up. And then you can go to Azure Metrics and see how is it doing. Do you need to adjust it further or not? You can set up a range, go see what's happening, what's the load on your cluster. Perhaps you need to change the upper limit a little bit because of performance reasons. Maybe you need to change the lower limits a little bit for cost reasons. And maybe you need to shift between load-based and schedule-based. So all of that becomes possible. So we have actually seen a lot of customers benefit a lot, and depending on workloads and patterns, we've seen customers save sometimes 50% of their cost using autoscale. All right, so let's talk about tools. HDInsight is all about developers and data scientists. So let's talk about the choice of development environments. Now, Visual Studio and VS Code certainly, it's very popular, but we also support IntelliJ and Eclipse as well. We've added some features relatively recently where the IntelliJ plugin can actually support remote distributed debugging of Spark jobs. For VS Code in particular, we have added support for the Jupyter plugins experience. And so if you wanted to run Jupyter against a secure ESP cluster, enterprise security package cluster, you can do that using VS Code. If you're a data scientist and you want to use Zeppelin, you want to use Jupyter, we support both notebook formats. RStudio is available as well if that's what you choose to use. If you're an administrator and your main job is to write code that to automate the function of managing and monitoring your HDInsight clusters, then you have a choice again of .NET, Java, Go, etc. For all your needs. But we also work very closely with a number of different ISVs to make sure that their applications work very well with HDInsight. And the way we do that, we actually look at the entire pipeline from data ingestion to data prep and management, analytics, and BI. And certainly, from a data governance and compliance standpoint, we cover the entire breadth of scenarios. And we have partnered with specific ISVs for each one of them and made them available here. I want to specifically call out Vandisco for data ingestion, Unravel for application management, and others as we have moved forward with HDInsight. For your scenarios, if there are some ISVs that you don't see in this list, please feel free to contact us. We are always expanding this list as our customers demand. Okay, so we've covered everything. So now comes the last bit. How do you migrate? So I hope by now, through all the previous information that I presented, you know that HDInsight really has everything that you need. You need Hadoop, we have Hadoop. You need Hive, we have Hive. You need Spark, we have Spark. We have, at the end of the day, pretty much all the projects that you are probably running on premises. We have support for it. If you need to extend for any reason, you have your own libraries, etc., you can do that. We have ways to extend and customize an HDInsight cluster. If there are things, for example, Impala. Impala is not something we natively support in HDInsight, but we have had several customers who have taken their Impala scripts and converted them into Hive, a Hive LLAP in particular, for interactive queries. So though that's feasible too. However, migration can seem like a daunting task. And it is. There are lots of, as we went through, lots of different things to consider as you decide and go through the process of migration. So we have broken down migration into several phases. The first phase is your assessment and design, where you're perhaps going through some initial training. Your employees may or may not be familiar with the cloud, with Azure, and you're sort of going through that. You're building POCs. You're trying to understand what your TCO will look like, and therefore what your expected return on investment is going to be. So all the business decisions are being made. Some POCs are being built. Once you have chosen that, then comes the actual migration process, where you are migrating the data, you're migrating the code. Again, because of its open source roots, hopefully your application itself doesn't have to change a whole lot from on-premises to the cloud. But you're retrofitting at the end of the day, your workload, your data. And last but not the least, you need to make a decision on how you're going to cut over to the cloud. Your applications are perhaps running on premises. So do you decide to run both your cloud system and your on-prem system for some time in parallel? If you do, then how do you keep the data in sync? If you decide to cut over, how are you going to cut over? When do you cut over? These are all important questions that you have to think through. But you're not on your own. We have programs in place at Microsoft in the HDInsight team where we can help accelerate each step of your migration process. In the assessment phase, we do work very closely with Unravel and their application management suite, performance management suite, where they are able to do an assessment automatically on your on-premise Hadoop or Spark cluster and give you a bunch of recommendations on what your cloud HDInsight cluster would look like. For the actual data migration, Azure certainly has a whole bunch of features. Azure Data Factory is a capability that you could use. Databox is another one for bulk moves of data. Also WANdisco. This is an ISV that we work with very closely. WANdisco is now available in Azure itself as a way for you to move data and maintain active copies both on the source system as well as on the target, which is Azure. And last but not the least, when you do decide, when you're making your decision as to whether to cut over or do a parallel operation, that's where WANdisco can also help with an ongoing. If you decide to do a parallel operation, then WANdisco can actually help in that scenario as well. So, if you're interested in this, talk to your account team, reach out to me and my team, and we'll certainly help you make sure you're making the right decisions for your migration and get to HDInsight and Azure as quickly as possible. So, last but not the least, on Azure, you have a lot of choices. I'll go back to the migrate, optimize, and modernize pattern. Lots of choices. HDInsight is typically the first step that a customer will take to lift and shift their applications from on-premises to the cloud. But once you get there, your choices, you still continue to have choices with things like Azure Synapse, for example. So you can come to the cloud with HDInsight, but as you modernize using some of perhaps the data warehousing technology that we have built as part of Synapse, SQL on-demand functionality, as well as Spark as a job service on Synapse. These are all available to you very deeply and seamlessly integrated together. And over time, you will observe that HDInsight and Synapse will work very closely together, sharing Metastore, etc., as we bring these things together. So the best of both worlds, both the open source world as well as deeply integrated analytics on Azure world through Synapse. So with that, that's I have some links here for you for some additional resources where you can go and learn more about HDInsight. Keep up to date with newer features that we are releasing on a very regular basis. And if you just want to learn about HDInsight, some learning modules, etc., to train yourself and your team, that's available too. So thank you again for spending the time listening to this presentation. I hope to hear from you soon.